Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, Subject Code OEC 754, Unit 2, Topic Respiratory Measurement, Blood Pressure, Temperature, Pulse Measurement. Objective to learn about the concepts of body temperature and their measurement. First one, we are going to see respiratory measurement. The exchange of gases in any biological process is termed as respiration. It is a process of taking in oxygen from the environment, transporting the oxygen to the cell, and also removing the carbon dioxide from the cells, and also exhausting their waste product into the atmosphere is called as respiration. In the human body, the respiration can be classified as internal respiration. It is the exchange of gases between the bloodstream and nearby cells inside the body is called internal respiration. The next one is external expiration. It is the exchange of gases between the lungs and bloodstream inside the body is called external inspiration. Breathing consists of two phases. Inspiration, it is the process of taking in air. Expiration, it is the process of blowing out air. Here you have some various laws are there involved in the understanding of respiratory functions. Boyle's law, it states that at constant temperature the volume of gas varies inversely with the pressure. Next one is Charles' law. It states that at constant pressure, the volume of gas is directly proportional to the absolute pressure. Henry's law, it states that if the temperature is constant, the quantity of a gas that goes into a solution is directly proportional to the partial pressure of that gas. Dalton's law, it states that the total pressure exerted by a mixture of gases equal to the sum of the partial pressure of various gases. Instrumentation for respiration measurement. The mechanics of breathing can be derived from measurement of lung volumes at various levels and conditions of breathing. Pressure within the lungs and the thorax with respect to outside air pressure and instantaneous airflow. First one is spirometer. It mostly widely used for the laboratory instrument for respiratory volume measurement is the spirometer. That means it is possible to determine all lung volumes and the capacitors by measuring the amount of gas inspired or expired under a set of conditions during the specified time interval. Here also it is used to measure the vital capacities and also forced expiratory volumes can be performed on a spirometer. In the spirometer, it consists of a movable bell inverted over a chamber of water. This ball contains air above the water line which is used for breathing. The next one is measurement of residual volume. From the spirogram and the outputs of some of the other requirements, all the lung volume and the capacities can be determined except those that require measurement of the area remaining in the lungs and airways after maximum expiration. The closed circuit technique. In this technique, it involves breathing from a spirometer which has a known volume of air with a fixed concentration of helium gas under the inverted cell. That means the patient is made to breathe this air for a considerable period of time to complete mixing of gas in the spirometer. Then the lungs can be assured. Here, the concentration of helium gas in spirometer is a measure of the residual volume. The nitrogen washed out technique. In this technique, it involves the inspiration of pure oxygen and expiration in a spirometer which has oxygen in the inverted bell. That means during breathing, we have almost 78% nitrogen remaining in our lungs. A nitrogen washout curve can be obtained with each breath. That means the residual volume can be found out from this curve only. Next one is intra-alveolar and intrathoracic pressure measurement. It is an airtight box in which the patient is made to sit. The patient breathes air from within the airtight box through a tube provided inside the box. Here when the patient and the box are considered, then the total air in them is the sum of the air inside the box VB and the air in the lungs of the patient VP, that is intrathoracic volume V total equal to VB plus VP. On small change we get del of V total equal to del of VB plus del of VP, but del of V total equal to 0 as air box is stripped. So therefore del of VB equal to minus del of VP. As per Boyle's law, we have VP is a constant. Here PP is the intrathoracic pressure, or del PP equal to minus del P. From equation 1 and 2 we have del PP equal to del VP. Next one is airway resistance measurements. In this, airway resistance is determined by simultaneous measuring, that is R equal to Pi minus P-atm divided by F. Here R represents the airway resistance, Pi represents the intra-alveolar pressure, P-atm represents the atmospheric pressure, F represents the airflow. The next one is measurement of blood pressure. Here blood pressure is considered as a good indicator of the status of cardiovascular system. There are two pressures, they are systolic pressure and diastolic pressure. In the systolic pressure means it represents the maximum pressure reached during cardiac ejection is called as systolic pressure. Diastolic pressure, it represents minimum pressure occurring at the end of a ventricular section. It is termed as diastolic pressure. In this, the normal value in the basic circulatory system are arterial system 30 to 300 mmHg, venous system 5 to 15 mmHg, pulmonary system 6 to 25 mmHg. There are two types of methods. First method is direct method. Blood pressure measured by indirect method by using a spirometer and a stethoscope. In this indirect method or non-invasive method, the spirometer consists of a cut-off rubber bladder. It is inside an inelastic fabric covering that can be wrapped under the upper arm and attached with either hooks or Velcro attachment. In this, the cutoff is placed on the upper arm and expanded artery blood can flow, but only when the arterial pressure exceeds the pressure in the cutoff. Suppose if the pressure exceeds above systolic pressure, no sound can be heard through the stethoscope. Suppose if the pressure gradually reduced as soon as cutoff pressure falls below systolic pressure, a small amount of blood rushes the cuff and cork-off sounds begin to hear through stethoscope. The next one is Creographic method. In this method, a set of 3 electrodes were attached to the cuff or placed in constant with skin. That means a high frequency current source operating at 100 kHz is connected to the electrode A and C. In this, between any two electrodes are measured before pressurizing the cups and modulated in accordance with blood flow pulsation in the artery. Here also, we can take place here to the only differences diastolic pressure and systolic pressure are shown by only the indicators. The next method is direct method or invasive method. A direct method of pressure measurement is used when the highest degree of absolute accuracy, dynamic response and continuous monitoring is required. In this, direct measurement of blood pressure is usually obtained by any one of the 3 methods: percutaneous insertions, catheterization, implantation of transducer in a vessel or in the heart. First, we are going to see the catheter tip probe. In this type, the sensor is mounted on the tip of the probe and the pressure applied on it are converted to the proportional electrical signal. Next one is fluid-filled catheter type. In this type, the transmitted pressure applied on its fluid-filled columns to an external transducer. Here the following diagram shows the typical setup of a pressure measurement system by direct method. That means the transducer is excited with a 5 volt DC excitation. In this, the modern pre-amplifier processing pressure signal is the isolated type. Here, the input stage is a differential circuit. It will amplify the pressure changes and it's sensed from the patient connector circuit. Then the gain of the amplifier can be adjusted depending upon the sensitivity of the transducer. The next one is temperature measurement. It is one of the oldest known indicators of the general well-being of a person. There are two types of temperature measurements. First one is systematic temperature. It is the measure of the internal regions of the body. Systematic temperature most accurately measured at the tympanic membrane in the ear. It is also the control of the body. It is located deep within the brain. Warm, cooling, ambient temperature, production of perspiration due to segregation of the sweat glands and increased circulation of blood. Measurement of systematic body temperature. It is still the standard method or measurement. These devices are inexpensive, easy to use and sufficiently accurate. Two types of electronic temperature sensing devices are found in biomedical applications. First one is thermocouple, a junction of two dissimilar metals that produces output voltage nearly proportional to the temperature at that junction with respect to a reference junction. Thermistor, a semiconductor element whose resistance varies with the temperature. The variable resistance derives formed in the discus, beads, rods or other desired shapes. Formula RT1 equal to RT0 e to the power beta divided by 1 by T1 minus 1 by T0, where RT1 represents resistance at temperature T1, RT0 represents resistance at reference temperature T0. E is the base of natural algorithms. Beta temperature coefficient that ranges from 3000 to 4000. T1 temperature at measurement is taken. T0 reference temperature. Next one is skin temperature. It is also a surface or skin temperature is also a resultant of a balance, but the balance between the heat supplied by blood circulation and cooling by conduction, radiation, convection and evaporation. Next we are going to see the skin temperature measurement. It is a function of surface circulation, environmental temperature, air circulation from which the measurement taken and perspiration. Thank you.